So the next video I'll be doing is the oxidation reduction for water, or the synthesis of water, which is H2O plus O2 yielding H2O. And you might actually know the answer, or might know the balanced equation for this problem, but I purposely picked this as a simple representation of how oxidation reduction works. And it pretty much applies to every equation that has a transfer of charge. So the first thing we do is to apply the oxidation states. Now, since hydrogen and oxygen are both in their atomic states, they both have a charge of 0. In H2O, water has a charge of -2, and hydrogen has a charge of +1. Now, you can take this straight from the atomic, from the reference table, or you can deduce that since oxygen almost always has a charge of -2, you'll need to have two positive ones to balance the -2 out and make that equal to 0, since all molecules are equal to 0. Now we need to identify what becomes reduced and what becomes oxidized. So by definition, oxidation is the loss of electrons. Just write that out again. And reduction is the gain of electrons. And we can see, let's take a look at the hydrogen. The hydrogen is going from a 0 to a +1. So we know, when we write our half reaction out, that this is oxidation. And O2 going to O -2, that process is reduction. So now that we have established what's become oxidized, what has become reduced, we can write out a half reaction. Split this into two sides. One is oxidation and the other is reduction. And we're simply going to take each of these parts and move them into our separate equations here. I'm going to write out H2 with the charge of 0, going to H2, and we're going to leave out everything that doesn't have to do with hydrogen, just going to use the hydrogens. And since these two are already balanced in terms of atoms, we have 2 hydrogens on this side and 2 hydrogens on that side. We don't have to worry about that, we just have to look at the charge. Now, if there's a charge of 0 on this side, that means the overall charge is 0, and we look at the right side, there are actually 2 hydrogen atoms, and each one of them has a charge of +1. Therefore, we're going to have an overall charge of -2 on this side, a positive 2 on this side, and a charge of 0 on this side. Which means that we're going to want to add electrons to the higher number. So whichever one is higher is where you're going to add the electrons, because when you add an electron, you're really subtracting that number, because electrons are written like that and with a negative charge, and so when you're adding a negative number, your process is really just subtraction. So we're going to add 2 electrons to this side. Moving to the reduction side, hydrogen is being oxidized, so oxygen is being reduced. Take O2, and that yields O -2, and here we have to balance in terms of atoms as well. We're going to add a 2 as a coefficient here. You can't add it here because that would be changing the state of the atom, but we can add it here as a coefficient that balances out the atoms. And now we're going to look at the charge. Always write out your oxidation states above your elements. If there are 2 oxygens with a -2 charge, that means the overall charge is actually going to be -4. The charge on this side is going to be a 0, so we know that we're going to have to add either to the left side or the right side 4 electrons, since we have 0 to -4. Now, to which side do we add it to? Well, you can memorize that in oxidation you add to the right side, or reduction to the left side. I'm pretty sure how that works. But the best way to think of it is intuitively. And so you're going to want to add, or in this case you're going to be subtracting, you're going to want to add that negative number to the side that has a higher value oxidation state. So we're going to add 4 electrons to this side, because 4, so when you subtract 4 from 0, you're going to have a -4, which is going to balance out to this number right here. You're going to add 4 electrons to this side. Our next step is to combine these 2 reactions. Now, the only way to combine 2 reactions is to make sure that the transfer of electrons on each side is equal. You do see that here there are 2 and there are 4 over here. So there needs to be some kind of multiplier to balance out these electrons. You can only combine two reactions if the number of electrons on each side are equal. And you'll notice when we read it out that electrons on this side are electrons in this equation on the right side, and the electrons on this side, this equation on the left side. Or excuse me, I confused that. Left side and right side over here. So let us multiply everything on this equation over here by 2 to match that 4, because when you'll be multiplying 2 times 2, you'll have 4 electrons. But whatever you do to 1, you'll have to do to everything. So that's why we're multiplying all the parts of the equation by 2. So you're going to have 4 electrons plus hydrogen, and that is our oxidation side, and our reduction side stays the same because we're already balanced in terms of electrons with 4 and 4 match. So now to combine these two, we're just going to simply, we're looking at this equation now, we're going to simply combine everything on the left side together, and everything on the right side goes together as well. So that means we're going to be left over with 2H2, take the O2 on that side because that's the left, yielding H2 plus 2O negative 2. Now, finally we can add these electrons to each side, and you'll have electrons on this side of the equation on the left, on the right, and electrons on the left over here. So you're going to add them to their respective sides. But you don't need to do that because what you've done by multiplying this side by 2, you're actually canceling out the electrons. So that's how you know that you've completed the oxidation reduction problem correctly, if your number of electrons have canceled out at the end. So now all we have to do is simply put these numbers, these coefficients, back into our original equation. We can write it out again, but I've run out of space. All you're doing is going to write these back into the original equation. You're going to make 2H2, a 1O2. Hydrogen stays the same, but there are 2 oxygen negative 2 atoms. So we're going to put that over here. That's going to affect the hydrogens, but it doesn't matter because we've accounted for that. And once you've gone to this point, you know, and you complete all your processes correctly, you know you did the problem right, since I have canceled out the electrons. So in the end, we know that it's 2H2 plus O2 yields 2H2O. Now you could have gotten that using simple balancing techniques, but some of the problems become more difficult, requiring you to use oxidation reduction techniques, and therefore it's not so easy. So by using a simple equation like this, I can demonstrate that we can balance it 2 ways. The original way you learned probably in the beginning of the year, and the second way using oxidation reduction, because oxidation reduction in the end is simply balancing a more difficult equation.